So let's solve one more interesting problem which was asked in, I think, gate 19. If we read the question says a linear Hamming code is used to map a 4-bit messages to 7-bit code words. It means we are using a error control code, that is Hamming code, and in that code a 4-bit message is converted to 7-bit code words. So the encoder mapping is linear, and they have also specified that the encoder mapping is linear. And I have underlined this word linear because this word is very important for in order to solve this question. If the message, and now we have two more information that the message 0001 is mapped to the code word 0000111, and the message 0011 is mapped to the code word 1100110. Then the message 0010 is mapped to. So they have asked that we have given that message M1, if this is M1, M1 is mapped to C1, and message M2 is mapped to C2, then what would be the corresponding code word for this message, which we represent by M3? So what we have just said there, that this message M1 is mapped to the code word C1, the message M2 is mapped to the code word C2. And if you observe our message M3, which in the question is asked, I mean the question has asked that what is the corresponding code word of this message, right? So if you observe properly, you will see that M3 is nothing but addition or XOR of the message word M1 and M2. If we do bitwise XOR of M1 and M2, we will get M3. You can just see 1 XOR 1 is 0, 0 XOR 1 is 1. So M3 is nothing but the XOR or the addition of the message words M1 and M2. And since they have specified that the mapping is linear, so the addition in the message domain, in the message word, if we M3 is summation of M1 and M2, then C3, which is the corresponding code word corresponding to the message word M3, will be summation of C1 and C2. So if you just sum it, you will get the answer. So our answer is 1100001. So it's a hardly 10-second question, 10 to 20 seconds question. And the whole point, if you just underline this word that the mapping is linear, you can solve this question very easily. Now you can ask that how can you say that the C3 is we will get C3 as a summation of C1 C2. So I have just explained it. So let's that we denote the mapping by L, right? The mapping, this is a mapping, right? Let we denote it by L. So we map L, the message word M1 is mapped to C1, and L is the mapping which maps M2 to C2. So the question is, the same mapping L, how would it map to M3? I mean, what would be the code word corresponding to M3? So you can write M3 as M1 sum of M2, and by using the superposition property, because linearity property states that you have to satisfy superposition property, right? The summation of the input would correspond to summation of the outputs, and there is one more property, that is scaling property, that we'll discuss when we get some question. But for this question, superposition property is it is only superposition property is required. So we can see that this mapping on M1 plus M2 is nothing but LM1 plus LM2. So LM1 is nothing but C1, and LM2 is nothing but C2. So C3, this is nothing but C3. So we get C3 by just doing bitwise XOR of C1 and C2. So this will give you the